You've completed a mission deep in the wilderness. But when you try to leave, you realize that your electric vehicle is completely out of power, and there is no charging station anywhere. Fortunately, the vehicle is equipped with emergency battery assembly materials. You can assemble the batteries and use them to transfer their power into the vehicle. To get this car running, you'll need to put in the energy of at least 4 full batteries. Only when the power equivalent to 4 batteries fully charges the vehicle, it will start again and carry you away from this place, back to the city. Now you check the inventory. For positive energy sources, you have 1 orange orb and 1 red orb. For negative energy sources, you have 1 green orb and 1 blue orb. You also have many battery chambers, a box which contains battery membranes and abundant electrolyte for activating the orbs. You open the assembly manual which explains that how to build a battery. All you need to do is, first, place a battery membrane inside the chamber to divide it into positive and negative sides. Second, put 1 positive orb and 1 negative orb into their respective positions. And finally inject the electrolyte into the chamber to activate the orbs. Then, you can use this battery to charge your vehicle now. So far, everything seems perfectly balanced. However, you notice the first complication. Once a specific positive orb and negative orb make a battery and have successfully charged the power into the vehicle, the pair of these 2 orbs develop a permanent repulsion. That is to say, that same pair can never be used together again. This means the 2 positive orbs and the 2 negative orbs form 4 distinct pairings, and all 4 pairings must be used exactly once. What's worse, the second complication is far more dangerous. Once an orb is activated by the electrolyte, it begins to emit radiation. And each of the 4 orbs emits a different types of radiation. An orb is safe when exposed only to its own radiation. But if it is exposed to the radiation of any other orb, it will instantly explode. Battery chambers and membranes can block radiation, and the electrolyte will not be contaminated. However, radiation will contaminate the surface of battery chambers and membranes it touches. The contaminated surface will also begin emitting radiation, and this secondary radiation is also strong enough to detonate other orbs. For the battery membranes, you stack multiple membranes inside a single battery for separating is also available. However, if 2 membranes, each contaminated by a different radiation, are placed face to face, both sides become infected with both radiations. And from that moment on, using them again will cause every orb to explode. Now, you double-check your supplies once more. The orbs are sufficient, the chambers are many, and the electrolyte is plentiful. The battery chambers and electrolyte can be disposable, and you do not need to reuse them. Except for one thing. When you open the box of the battery membranes, you notice the real problem. You only have 2 battery membranes. So here's the puzzle. How can you build the 4 batteries to charge the vehicle with enough power, using all 4 orb pairings, and do it safely, with only 2 battery membranes? Please think carefully, and use your advanced brain. At first, this puzzle looks like a simple resource problem. You have enough orbs, plenty of battery chambers and adequate electrolyte. But you only have 2 battery membranes. So, before building anything, we need to ask a critical question. How should these membranes be used so that they survive all 4 batteries? The most intuitive approach is this: use 1 membrane per battery, one at a time. So let's imagine trying that. In the first battery, the membrane becomes contaminated on both sides by the radiation of the two used orbs. In the second battery, the other membrane is used and it also becomes contaminated on both of its sides. Now both membranes are fully contaminated. When we attempt the third battery, it turns out we can barely make it work by overlapping the two contaminated membranes together. The outer faces of the stack are exposed to the new pair of orbs, so the third battery can function. But the inner faces are cross-contaminated by sticking together. Therefore, for the fourth battery, all four surfaces are incompatible with the remaining pair of orbs. It runs into a dead end. Since using a single membrane at the beginning always leads to a dead end, it's natural to consider starting by stacking both membranes together. Once we see that, the solution almost jumps out at us. To keep things clear, we label the membranes as membrane X and membrane Y, each with a positive side and a negative side. For the first battery, place both membranes together in a single battery chamber. Positive side of membrane X faces the positive side, and negative side of membrane Y faces the negative side. Insert the orange orb on the positive side and the green orb on the negative side, then activate the battery. After this, the positive side of membrane X carries orange radiation, and the negative side of membrane Y carries green radiation. For the second battery, let's separate the membranes, then place membrane X alone into a new chamber. Orient it to make its contaminated positive side faces the positive side, and its clean negative side faces the negative side. Then insert the orange orb and the blue orb and activate the battery. After that, the negative side of membrane X carries blue radiation. For the third battery, we take membrane Y and orient it so that its contaminated negative side faces the negative side, and its clean positive side faces the positive side. Insert the red orb and the green orb and activate the battery. At this point, all four membrane sides are contaminated, but each side carries only one type of radiation. Now we come to our final battery. We place membrane X and membrane Y together again, with positive side of membrane Y facing the positive side, and negative side of membrane X facing the negative side. These outer sides already match the radiation of the remaining orbs. The inner sides become cross-contaminated, but they are sealed inside, touching no orbs at moment and will never touch any orbs in the future. After activating our final battery, our vehicle can be fully charged. Then, the car starts, and you finally leave the wilderness, safely on your way back to the city. If you enjoy puzzles like this, and want more problems that challenge your logic, please subscribe to Advanced Brain, and keep thinking smarter.